So now we're going to have a circle and a line. So a circle, like this, you could have a line that doesn't intersect the circle at all, no solution. You could have a circle, well, pretend like that's a circle. And the line is only touching, it doesn't look very good, but in one point. Now when that happens, we say the line is tangent to the circle. Yeah, tangent, like we've used that word before in trigonometry, but different meaning. So it's not a function here. So we just say the line is tangent to the circle. Okay, but you're going to hear that in your calculus class. Okay, in this case, there's one solution. Or you could have a circle, and then maybe the line just, goes through the, well, that doesn't look very good. Try to draw it better. A circle, and then the line goes through in two places. And so we have two solutions. Okay, so those are the situations we could have. And now here's our system. Find the intersection of the given circle and the given line by substitution. So they want us to do it by substitution. What we're going to do, we have an equation, this bottom one that's linear. We already have y equals 3x minus 5. So let's just use that and plug it into the other equation for y. And then that's going to give us this equation. X squared plus 3x minus 5 squared equals 5. Now this is some good old algebra. No trigonometry in here. Okay, anyway, and so you can hopefully just do this, stop the video and do it on your own. So I get that if I multiply it out, and then I get 10x squared minus 30x plus 20 equals 0. If I factor out a 10, or I could just divide everything by 10. This looks very similar to that other equation we worked with, right? So it factors into x minus 2 times x minus 1. And so we get values for x. X could be 2, or x could be 1. So it's looking like we're going to get two solutions here. Now we still have to find y. So we've got to use that equation. Y is equal to 3x minus 5. So the first one, if I plug in a 2 for x, I get y equals 1. You work that out. Okay, so that's one ordered pair, 2, 1, right? X, y. Now, the other ordered pair is when x equals 1. So you get y equals 3 times 1 minus 5. Which would be what? Negative 2. And so we get another ordered pair, 1, negative 2. Now, let's do, so we say these are our solutions. Okay. And I'm just putting a box around it. You could put it in set notation. Two solutions, 2, 1, and 1, negative 2. And, you can write it that way as well. Okay, but now let's look at the graph here for a minute. If we were to graph this, this is the standard form of a circle centered at the origin. And it has a radius, so just in that top one, the radius is equal to the square root of 5. So you have to remember a little bit about circles. X squared plus y squared equals r squared. Okay, so that's centered at the origin. Radius of square root of 5, which is approximately like 2.2 or 2.3, 2.2. Okay, and so, here I am at the center. There's the center at the origin. And I go out like, 2 and a little bit in each direction. And then I try to draw a circle. You can get a compass. Oops. Well, anyway, some days I draw better circles than others. Okay, but that's the circle, more or less. And then you can graph this line. You know the intercept is negative 5, so you're down here at negative 5. And the slope is 3. So it looks like the line's going... Ooh. like that. And let's see if our answers look pretty close to the graph, even though my graph's not great. Where is the point 2, 1? 2, 1 right there. And where is the point 1, negative 2? 1, negative 2, right there. So yeah, it looks like our graph is true to what we said algebraically for the solutions as well.